Yo guys, welcome back to this channel. Nice to see everyone again. And for today's video, we will focus on the topic 5.4, the chemical property of alcohol part 1. I separated the chemical properties into two parts. This is the part 1 of it. And in this part, we have 5 reactions that we will go through. The first reaction is the chemical reaction with group 1 metal and group 2 metal. The second, oxidation by using KMnO4 and K2Cr2O7. The third is the oxidation again, but with PCC in CH2Cl2. We'll look at the differences between two of these oxidation. Next, we'll look into your esterification. Last but not least, we'll look at dehydration of alcohol. Let's jump straight into the reaction with group 1 metal. The example of group 1 metal that I have over here is your sodium and potassium. And we know that your group 1 will always be a positive 1 charge. In the other words, your sodium will always be Na positive or your potassium will always be K positive. And what happens when alcohol react with the group 1 metal? So when the alcohol react with the group 1 metal, you realize that the changes happen to the OH and also over here. If you look carefully, it's actually the hydrogen is replaced by the Na, sodium metal. So you have your alcohol, you have your O and the H, and we know that the O is actually a O minus, the H is a H plus. So what happened is the H were being removed and replaced by the Na positive group 1 metal. That's why you form a RO Na. Okay? And the hydrogen that you remove will then become the hydrogen gas. Okay? And that is the reaction of alcohol with your group 1 metal. Bear that in mind, your alcohol will remove the OH. This is the H that you will remove. Okay? And replaced by the Na over here. The same thing apply when you react with another group 1 metal, which is your potassium. The same thing happen, guys. OH, the hydrogen being removed, the hydrogen replaced by the K. Alright, the potassium K, and then you produce your hydrogen gas from this hydrogen. Okay, same story because your oxygen will be your O minus, your K will become a K plus. So O minus, K plus become OK. Alright, simple. That is the reaction between your alcohol and your group 1 metal. Next, let's look at some example. So over here, you have your alcohol. You have your group 1 metal. And what happened is, your alcohol, everything shall remain unchanged. And your OH will remove the hydrogen substituted by the potassium, forming half of the hydrogen gas. That's it. The hydrogen being removed, alright, the K substitute the hydrogen produce hydrogen gas. Another example, even though it's a cyclic, it's a cyclopentanol, but we are still looking at your OH, remove the hydrogen, substitute the hydrogen with the Na. So you will have your cyclic remain unchanged, your oxygen right now holding sodium and produce half of the hydrogen gas. Make sense? Simple. Next, let's look at the reaction of alcohol with your group 2 metal. So what happened when you react with group 2 metal? The example of group 2 metal that I give to you is your magnesium, calcium, barium. And we know that when they are group 2 metal, there will always be Mg2+, Ca2+, Ba2+. That is your group 2 metal. Let's look at the reaction with alcohol. And if you look at it, the reaction looks slightly more complicated than your group 1 because your alcohol ROH, right now your alcohol, become R single bond O with a bracket 2. So the question is, why do I need 2 of it? Reason. Magnesium over here is a group 2 metal that will become Mg2+, 2 positive. While oxygen, when you remove the hydrogen, you will then become R, O minus, and also H plus. So the H plus, as always, will become your hydrogen gas. So your O minus right now is a negative 1. But my Mg2 plus is a 2 positive. So how many O minus do I need to balance with 1 Mg2 plus? I need 2 of the O minus, so that I will have 2 minus and 2 plus. Therefore, your alcohol over here, you will need 2 of your alcohol to combine with 1 Mg. Okay, so it's something like this. RO minus, R oxygen minus will then react with your Mg2 plus. So 2 positive, 1 minus, 1 minus. Okay, that's why you need your alkoxide ion, RO minus, in the bracket with a 2. Alright, simple. Let's look at some example. The first example that I have over here, still your alcohol, but with your Mg2 plus. We know that that is your group 2 metal. So group 2 metal is your Mg2 plus. And the product that you will form, everything remain the same. Just copy that. And what is changing is your hydrogen being removed. So you have your O over here. And your O over here, guys, will have 2 of it. Okay? Bonded with your Mg1. So bracket 2 Mg. That is the way that we write. Plus with your hydrogen gas that you produce from the hydrogen that you remove. So oxygen will remove the hydrogen. The OH will remove the H. Bonded with your group 2 metal with a Mg2 plus. So 2 plus, O minus. So we need 2 O minus to balance off with 1 Mg2 plus. Next, same thing over here. You have your calcium. You know that your calcium is a group 2 metal. Therefore, when you write your product, everything remain the same. But the alcohol will remove the hydrogen. So you have your O bonded over here. Your oxygen right now having 2 of it, Ca2 plus. That is your Ca bonded with 2 of the O minus ion, plus the H2 gas. And that is the differences between the reaction of alcohol with your group 1 metal and your group 2 metal. Only because your group 2 metal will give you Mg2 plus, Ca2 plus, and Ba2 plus. But oxygen will only give you RO minus. Okay? Simple? Easy. Let's move on to the next reaction. Oxidation. Oxidation will be slightly long over here because we have a lot of different conditions. Okay? Let's take a look. Oxidation is separated into strong oxidizing agent and also mild oxidizing agent. Strong oxidizing agent means they are very strong, that can do a lot of things. Mild oxidizing agent means it's slightly weaker. It is still strong, but it's just slightly weaker than the strong oxidizing agent. The example of the strong oxidizing agent that I can have is KMNO4, H plus heat. So you have your potassium permanganate in the acidified condition with the presence of heat. Or you can use your potassium chromate with the presence of H plus and also the heat. Alright, so both of this is the example of strong oxidizing agent. While for mild oxidizing agent, we only have one, which is PCC in inert solvent. Bear that in mind, this is your inert solvent that have nothing to do with your reaction. We only focus on PCC. And that is the 2 different oxidation process that we will look into by using different agent. Strong oxidizing agent and mild oxidizing agent. Let's start with the strong oxidizing agent over here. The example of strong oxidizing agent, again, KMNO4H plus heat or K2Cr2O7H plus heat. So these are the 2 strong oxidizing agent that we will always use. And let's jump straight into the first one. When you have primary alcohol, what happens when you undergo strong oxidizing agent? When primary alcohol being oxidized, you will form carboxylic acid. Example. Primary alcohol, the simplest that I can give to you is the carbon that holding OH, holding 1 carbon. holding one group of carbon. So that is my primary alcohol. And when I'm using my strong oxidizing agent, for example, KMNO4, H plus heat, what happened over there? First and foremost, you will remove one of your OH and one of your H. When you remove your OH and your H, both of them will then become double bond O. So everything remains unchanged at this moment. But when you remove the hydrogen, when you remove the OH, that will then replace by double bond O. Okay? Next, you have one more hydrogen. What happened to the hydrogen that's still attached to the carbon that holding the OH? When you still have hydrogen attached to the carbon that holding the OH, the hydrogen will also undergo oxidation. The hydrogen will then become OH. And that is your carboxylic acid. Can you see your COH over there? First and foremost, I want to insist one thing. We only focus on the carbon and the group that holding the OH. So this is the carbon that holding the OH. This is the OH. So we only focus on the carbon that holding the OH. First and foremost, what happened is the OH need to go out. The H need to go out. One OH, one H. Remove that. Replaced by double bond O over here. Next, your hydrogen. So what happened to the hydrogen when we still have one hydrogen on the carbon that holding the OH? The hydrogen will also undergo oxidation because we are having a strong oxidizing agent. So this strong oxidizing agent is actually providing you oxygen. When they provide you a lot of oxygen, your job is to take all the oxygen. Okay? So the hydrogen that we still have on the carbon that holding OH will then become OH, will be oxidized to become OH. And there is your carboxylic acid. So your primary alcohol, all your primary alcohol, when undergo strong oxidizing agent, it will definitely become carboxylic acid. With a condition, the oxidizing agent that you use must be either KMNO4H plus heat or K2Cr2O7H plus heat, the strong oxidizing agent. Okay? Simple. Next, let's look at some example of my primary alcohol over here. The primary alcohol is quite clear because the carbon that holding the OH right now is a primary carbon. So, what carboxylic acid will be produced? Let's try to expand that. We do not need to expand everything because we only want to focus on the carbon that holding the OH. So, expand this only. Do not need to expand everything. And this process requires strong oxidizing agents, so you can use K2Cr2O7, H plus, and the heat. Okay? And what happened over there, guys? First and foremost, focus only on the carbon that holding the OH and the rest of the thing. The whole carbon. Okay? The OH will be removed along with the H. And what happened after that? The rest of the thing that doesn't change remain unchanged. Keep that the same way. And then the carbon that remove the OH and the H will then gain a double bond O. Next, we still have one hydrogen that bonded to the carbon that holding the OH. What happened to this hydrogen? This hydrogen will also undergo oxidation to become OH. And this is the changes that happen to the carbon that holding the OH become O, double bond, and single bond OH. Make sense? Simple. And it's proven over here, all your primary alcohol will definitely become carboxylic acid. Bear that in mind. All your primary alcohol will definitely become carboxylic acid when you react with your strong oxidizing agent. Another example, when we have cyclic over here, same thing. We only focus on the carbon that holding the OH. So when you expand it, you only expand the carbon that holding the OH. Using your strong oxidizing agent, your KMNO4, H plus heat. And what happened? Focus on the entire carbon that holding the OH and the H, the rest of the H. So first thing, OH will be removed. Hydrogen will be removed. The rest of the thing that doesn't change, recopy. The carbon that removed the OH and the H gain a double bond O. And what happened to the hydrogen that's still attached to the carbon that holding the OH? The hydrogen will then become your OH. Oxidize means we give oxygen. Okay? And you can see over here, your primary alcohol again become your carboxylic acid when you are using your strong oxidizing agent. Simple, easy. Next, what happens when you have secondary alcohol? When you have secondary alcohol undergo strong oxidizing agent process, you will then form ketone. You will form a C double bond O. Bear in mind, ketone means C double bond O sitting in between carbon. That is your ketone. So let's take a look at your secondary alcohol. The example of secondary alcohol that I can give to you over here is this. A very simple secondary alcohol. And when this thing undergoes strong oxidizing agent, for example, you are using K2Cr2O7 H plus heat. So what happened, guys? Same thing, we will focus on the carbon and the hydrogen that attach to the OH. So this is the carbon that attached to the OH, right? And what happened is, we know that we are going to remove the OH, remove the H, and substitute by double bond O. So when we replace by double bond O, the things that doesn't change shall remain unchanged. Only the OH and the H removed, substituted by a double bond O. So this is the changes that happen. The question over here is, do this carbon still hold any OH? Do we still need to put any OH? No. Look at your carbon right now. It had complete 4 bonds. 1, 2, 3, 4. Enough 4 bonds. So the carbon right now is completed. Moreover, if you look at this carbon, the carbon that holding the OH has removed the OH and also has removed the H. And this carbon, do we have any hydrogen left on this carbon? No, we don't have any hydrogen left on this carbon, right? When there is no hydrogen left on this carbon, where is the OH come from? So you don't have OH and then you produce ketone. Your C double bond O sitting in between carbon and carbon. With one condition, your secondary alcohol right now undergoes strong oxidizing agent process to produce ketone. Simple, easy. Let's look at some example of it. And we all agree that your secondary alcohol will become ketone. So let's try and see whether all your secondary alcohol will become ketone or not. The first secondary alcohol that I have over here is this. So first and foremost, what do we need to do? We need to focus on the carbon that holding the OH. Okay? And then expand only the carbon that holding the OH and the hydrogen. So the rest of the carbon shall remain unchanged. Only expand the carbon that holding the OH and everything attached. Okay? And next, we are going to remove the OH and the H. And replace by what? You have 2 bonds right now. You remove OH, you remove H. So you have 2 bonds. We replace the bond with double bond O. So everything remain. But you remove the OH, you remove the H, replaced by double bond O. And that is your ketone. With one condition, we are using KMNO4 H plus heat or K2Cr2O7 H plus heat. Okay, any of your strong oxidizing agent. And I hope you can see over here that is your ketone. Okay. Another example when you're having a cyclic. I hope you can see that it's a secondary alcohol. This carbon right now holding to 2 carbon. So that is your secondary alcohol. Okay. So as always, this secondary alcohol still having 1 hydrogen if you look at it. Because we only have 3 bonds. So the another bond is actually your hydrogen. And what happened is, we will focus on the carbon that holding the OH and the H, right? And when this thing undergoes strong oxidizing process, what is changing? The OH will be removed. The H will be removed. When we remove the OH and the H, we replace the carbon with double bond O. And that is still your ketone. Because you have your carbon bonded to your double bond O is holding in between carbon. So that is also your ketone. So do we agree that all your secondary alcohol, when undergo strong oxidizing agent process, you will definitely getting your ketone. So over here, primary alcohol become carboxylic acid. Secondary alcohol become ketone. Alright, simple. Let's move on to your tertiary alcohol. So what happens when you are having tertiary alcohol? Tertiary alcohol, we know that it looks something like this. Holding to the carbon, holding to the carbon, and holding to your carbon. That is the simplest tertiary alcohol that I can give to you. And we know that to undergo oxidation, we need to form a double bond O. And to form the double bond O, your carbon that holding the OH need to remove the OH and one hydrogen. Then only you can become double bond O. You need to remove two bonds, then only you can become one double bond O. But guys, look at this carbon right now. This carbon holding one OH, and we know that we are going to remove this OH. After I remove this OH, do I still have any hydrogen to remove? No, we don't have any hydrogen anymore. So can this tertiary carbon hold a double bond? This tertiary carbon cannot hold a double bond anymore. You cannot hold a double bond O because there will be extra bond over that. You have 5 bonds around it. Wrong. Therefore, tertiary alcohol cannot undergo oxidation. Your tertiary alcohol will never able to undergo oxidation no matter how strong is your oxidizing agent. Why? Because your carbonyl carbon has no hydrogen atom. The carbonyl carbon over here is the carbon that holding the OH. This is your carbonyl carbon. Alright, carbonyl carbon is the carbon that holding the OH. Has no hydrogen atom. That's why you cannot undergo oxidation. So remember, your tertiary alcohol cannot undergo oxidation. Alright? Your tertiary alcohol will never able to undergo oxidation because the carbonyl carbon does not have any hydrogen atom. Remember that. Next, take a look at your tertiary alcohol. So this is your tertiary alcohol, the carbon that holding the OH. So this carbon right now is a tertiary because it's attached to 1 carbon, 2 carbon, 3 carbon. And look at this carbon right now. Do we still have any hydrogen attached? No. When you don't have any hydrogen attached, you cannot remove the OH and the hydrogen. So it cannot undergo oxidation because the carbonyl carbon has no hydrogen. This is the carbonyl carbon. The carbon that holding the OH is your carbonyl carbon. So remember that because your carbonyl carbon does not have any hydrogen attached. Simple. As a conclusion for our oxidation by using strong oxidizing agent, which is your K2Cr2O7H plus heat or KMNO4H plus heat, your primary alcohol will become carboxylic acid. Your secondary alcohol will become ketone, while your tertiary alcohol cannot undergo oxidation because the carbonyl carbon has no hydrogen atom. So this is the summary of the oxidation by using the strong oxidizing agent. Okay? Now, let's look at the oxidation by using mild oxidizing agent. We know that mild oxidizing agent is PCC in CH2Cl2. So when you have PCC in CH2Cl2, what will happen? Let's jump straight into your primary alcohol. We know that, again, your primary alcohol means is your OH holding only to one carbon over here. That is your primary alcohol. And when it undergo mild oxidizing process, it will then become aldehyde. You know that your aldehyde is your C double bond O H. Why it will only stop at aldehyde but not carboxylic acid? Focus only on the carbon that holding the OH. This is the whole carbon that holding the OH. So what happened, ladies and gentlemen? The OH again being removed along with one hydrogen. So when you remove one OH with one hydrogen, what do we replace the bond by? We replace by double bond O. So everything shall remain the same, but the carbon that holding the OH and the H replaced by double bond O. And since it's only a mild oxidizing agent, the PCC that you use in this process is not strong enough to oxidize everything because it's only mild. Alright, it's slightly weaker. It's not that strong. So when it's not strong enough, you cannot oxidize this hydrogen. As a result, the hydrogen will remain unchanged. Okay? And that is the reason why your primary alcohol will become your aldehyde. Make sense? Okay? And this is the main difference between your strong oxidizing agent and the mild oxidizing agent. Your primary alcohol will only give you aldehyde when you use PCC in CH2Cl2, your mild oxidizing agent. Let's look at some example of primary alcohol using the same primary alcohol. So what happened? You don't expand everything. You only expand the carbon that holding the OH. So this is my carbon that holding the OH. And when we undergo PCC in inert solvent, we only focus on the carbon that holding the OH and also everything of the hydrogen. And we know that we will remove one OH and any one of the hydrogen. And when we remove the OH and the hydrogen already, we will then replace the bond with a double bond O. And since it's only a mild oxidizing agent over here, therefore, the hydrogen shall remain unchanged because it's not strong enough to oxidize everything. Alright, it's only mild oxidizing agent, slightly weaker oxidizing agent. And that is your aldehyde. Make sense? Simple. Another example, when you have a cyclic, same story. Your cyclic over here, we will only expand the carbon that holding the hydrogen and the OH. And when you react only with your PCC in CH2Cl2, which is your mild oxidizing agent, alright, it's slightly weaker than the strong. And what happened? The OH remove, the H remove. So you only replace with double bond O. The hydrogen remain because it's not strong enough to oxidize everything. Easy? Simple. So your primary alcohol become aldehyde when you are using PCC in inert solvent. Let's look at the changes when we have secondary alcohol. Undergo oxidation by using PCC. You will still get ketone. This is the same. No matter it's a strong oxidizing agent or a mild oxidizing agent over here, which is your PCC, your secondary alcohol will be forever produce ketone. So ketone means your double bond O attached to a carbon, attached to a carbon, sitting in between carbon. Your secondary alcohol is something like this, holding the H. And when it undergo oxidation by using PCC only, in your CH2Cl2, the same thing, we only focus on the carbon that holding the OH. So the carbon that holding the OH having only one hydrogen. And what happened, guys? We need to remove the OH, remove the H. and substitute by a double bond O. So you have your CH3 remain unchanged, CH3 remain unchanged. The OH removed, the H removed, replaced by double bond O. Ketone. Alright, still your ketone. And it's proven that your secondary alcohol, no matter using PCC, which is your mild oxidizing agent, or your strong oxidizing agent just now, you will still getting ketone. Okay? So there is no changes over here. I won't show you any more example because they are the same. Let's jump into your tertiary alcohol. If your tertiary alcohol cannot undergo oxidation by using a strong, what happens when your tertiary alcohol using only a mild oxidizing agent? Of course, it cannot undergo oxidation again. Same reason, because your carbonyl carbon has no hydrogen atom. Bear that in mind, tertiary alcohol again is your OH, holding carbon, holding carbon, holding carbon. So this carbon that holding the OH has no hydrogen attached to this carbon. When there is no hydrogen attached, I can remove the OH, but I have no hydrogen to remove. So can I form a double bond O? No, you cannot form a double bond O. That's why you cannot undergo oxidation. So bear that in mind, your tertiary alcohol cannot undergo oxidation no matter what agent you are using. Strong oxidizing agent or mild oxidizing agent will still not able to oxidize your tertiary alcohol. Alright? Simple. The summary for the oxidation by using mild oxidizing agent is your primary alcohol will become aldehyde when you are using PCC in inert solvent. And this, to be honest, is the only changes compared to your strong. This is the only thing that different from your strong oxidizing agent. Your secondary alcohol will still become ketone, which is the same. Your tertiary alcohol still cannot undergo oxidation, which is also the same. So in the mild oxidizing agent, we actually only making changes to your primary alcohol produced aldehyde. Make sense? Simple. And we are done with your oxidation. Let's move on to the next one. The next that I have over here is esterification. So esterification obviously is to produce ester. Alright, so look at the ester that you produce right now. This is the ester that I'm looking for. And how do we produce this? Simple. You have your alcohol, react with your carboxylic acid with the presence of acid. You must have the presence of this acid. And then you'll produce your ester and also water as a byproduct. How is this process happen? The tips is over here. In the alcohol, we will remove the hydrogen that attached to the OH. So we remove this hydrogen. For the carboxylic acid, we will remove the OH. So this oxygen that loses the hydrogen just now will be then bonded to the carbon that loses the OH. So look at it. You have your O that come from this. Okay? And then bonded to the carbon that come from this. So this is the new bond that you form between the oxygen in the alcohol and the carbon in the carboxylic acid. So bear that in mind, the alcohol will remove the hydrogen from the OH and carboxylic acid will remove the OH straight away. Okay? That's it. Simple. Let's try an example of your esterification. So I have my alcohol over here. I have my carboxylic acid over here. Knowing that in your alcohol, we will remove the H. And in your carboxylic acid, we will remove the OH. And this is the oxygen that loses the hydrogen. While this is the carbon that loses the OH. And this process must happen with the presence of acid. So what do you form, guys? Everything remains the same except your O loses the H. And this O shall bonded to the carbon that loses the OH. So the carbon holding the double bond O, this carbon holding CH, CH3, CH3. And the byproduct over here, H2O. And the new bond that you form is between this oxygen and this carbon. This is the new bond that you form in your esterification. So simple. You remove the hydrogen from the OH. You remove the OH in the carboxylic acid. You combine between the O and the C. And that is your new bond and your new ester produced. Okay? Simple. And last but not least, you have your dehydration of alcohol. And we have learned this in the preparation of alkene, so I won't go any further. And what happened in the dehydration of alcohol? You need the presence of your alcohol. Undergo concentrated sulfuric acid and heat, and we remove the OH and also the neighboring H. Alright? And then you form a double bond between the neighbor carbon. And you remove water. We have learned this in your alkene, if you remember. If you don't, you can expand it. Expand the carbon that holding the OH and also the neighboring carbon. The carbon that sit next to it. So this is the carbon that holding the OH. This is the carbon sitting next to it and holding a H. And what we do is, we remove the OH, we remove the H. So this is the new bond that form. You form a new double bond. So everything remains the same, but then the hydrogen has been removed. You form a new bond over that with this carbon that's still holding the hydrogen but not the OH. The OH has been removed. So that is the dehydration of alcohol by using concentrated sulfuric acid and heat to produce alkene. Bear that in mind, the major product over here is determined by the SES rules, if you remember. And the type of reaction over here is elimination. We have talked about it in the preparation of alkene. You can check the video of preparation of alkene. Just do a simple example over here is your carbon that holding this OH. And when you react with your concentrated sulfuric acid and heat, you produce two products. You produce one over there. So you remove your OH over here and the neighboring carbon that holding the H. So you form a double bond over here and the CH3 remain. Or, one more, you form a double bond over here. Because this is also the neighboring carbon. So this neighboring carbon right now, remove the hydrogen and also the OH. So the double bond formed between this and this carbon. So we have two products over here with the presence of H2O. And according to SES rules, which one is your major product? Your major product is the highly substituted double bond that have more alkyl group. So this will be your major product. This will be your minor product. This is something that we have learned in the preparation of alkene. Okay? If you are not getting it, please check your topic 3, the video of preparation alkene in the playlist. I have a clear and simple version of explanation in that video about how to prepare alkene by using the same reaction, which is the dehydration of alcohol, more about SES rules and how to determine the major, minor. Alright, you can check this video. And that's it for the reaction of alcohol. And we have 5 reactions in the alcohol. Make sure you understand each and every one of them. And if this video able to help you, don't forget to give me a like and don't forget to subscribe to my channel for more videos. I'll see you in the next video and thank you for watching.